Happy New Year, beta. Hello? Hello? Can you hear me? Boys, can you
Yes,
hear me? Okay. So, good morning to all of you once again. We are beginning with a new chapter, that is motion. You can see over here the pebbles, or you can see the marbles moving. So, how does it move? The movement is called as motion. Now, I wish that one of you will take up the reading part. What is motion? This you must have already done in your earlier classes. This is a bit in detail. That's all. You know everything about motion actually. So we are going to revise it once again. So please, one of you start reading it up. And then if you wish, you can explain. And if you're not able to, then I'm there to explain it. Yes, beta, start. What is motion?
What is motion?
Yes, begin.
Ma'am, read करना.
Yes, yes.
Motion. It is the change in position of a body which, with time. Motion can be described in terms of the distance moved or the displacement.
Adjust your mic, beta.
This.
Yes. Yes. Complete it.
Yes, ma'am.
Complete the sentence.
Motion. It it is the change in position of a body with time. Motion can be described in terms of the distance moved or the displacement.
Okay. Now, for example, here is the body. Okay, this is the body. Now, this body is stationary, it is not moving. Say this body is A, it is not moving. Now, I give it a force, so it will start moving in this direction. Okay, and then it comes over here. So, this is the B position, this is the A position, and this is the B position. And it has taken the time T for it to move from here to here. You understand? So, what I will say that this body was in motion and it left A and reached B. Do you understand? And it took the time T for changing the position. Until unless a body changes its position, we cannot say that the body is in motion. So whenever we say that any body, any object is in motion, that means there has to be a change in position. Do you understand?
Yes, ma'am.
Okay? Fine. Now the difference between distance and displacement that I will give you in detail as we go through the slides. Right now, I'm not going to ask you to define what is actually distance and displacement. Both are a different terminology altogether. Distance, I've already showed you. Distance is that from A to B. Now, it could be 2 meters, it could be 3 meters, it could be anything. That is called distance. Displacement, I will talk about it later. Yes, please read it, Vita.
concept. In physics, motion is a change in position of any object with respect to time. Motion is typically described in terms of displacement, distance, velocity, acceleration, time, and speed. Motion of a body is observed by attaching a frame of reference to an observer and measuring the change in position of the body relative to that frame.
To that frame. Fine. Actually, motion that's how we have described is a change in position of what? Of an object. This we have confirmed that what is motion? Motion is a change in position of an object. You agree with me or not?
Yes, ma'am.
With what? With respect to time. That also you
Respect
agree?
to time.
Yes?
Yes, ma'am.
Yes or no? Okay. Now this motion will be described in the following slides in terms of display. This is what we are going to study. Displacement, distance, velocity, acceleration, time and speed. You understand? So these are the faculties that we are going to look into as we go into detail regarding this chapter. Now the question is, if I am moving, you are also moving, then how can I describe a motion? It's going to be very difficult. For example, I'm in a bus, right? I'm in a bus. And when I'm moving or I'm in a train, am I moving? I'm seated in a train. Yes or no? The train is moving.
Yes, ma'am.
The train is moving. And when I look out, I find that the trees are moving, the objects are moving. Why? Because I took the train as a reference. But the person who is outside the train, what he or she finds that I am moving in the train. Do you understand? So we take one reference always to define the motion of any particular object. Do you understand better? So there has to be a reference. Then only I can say that yes, this object is moving. You got my point?
Yes, ma'am.
Yes, ma'am.
The boys? Huh, okay. Fine. Now I'm in the class. Okay, I'm studying. Suddenly I see outside that a boy is running. So I become the reference. Then only I can say that the boy is running. You understand? Do you understand? One has to be difference.
Yes.
Then only I can define the motion of the other object. Okay? Fine.
Okay, ma'am.
Yes, start. I've taken the same thing in a different way so that you will understand it in a
Okay.
better manner.
Motion is defined as the change of position of an object with time, with respect to its surroundings. Similarly,
Okay.
an object is at rest when the position of the object does not change with time with respect to its surroundings.
Okay.
Example, a moving train is motion in motion because its position changes with time. Now consider a person sitting in the train. For someone standing on the platform. The person sitting in the train is is in motion, but for the co-passengers, the passenger is at rest
The
as the
person.
position of the person does not change with time.
Okay. Now what does it suggest? Okay, you read this also so that I can explain to you in a better manner. Read this paragraph too.
Hence, we needed to consider the surroundings or the point of observation while describing the state of motion of an object. The surrounding is called reference frame.
Fine. Now, can anyone explain if you wish to? We've already done the example. Yes, boys, can anyone explain what has been given over here? Yes. So what are we taking as a reference? The surrounding. Yes. Just now we talked about the example of a train, a person, only a person. Let it be you in a train, right? Is it clear? The train is moving because it changes its position with time. Now you are sitting in the train. Now, if someone is, for example, it's me, I'm on the platform. Okay, what I find that the train is moving. You are moving in the train. Am I right? Hello?
Yes, ma'am.
Yes, ma'am.
Yes? You understood? All of you, please, all of you participate. So I am on the platform. For me, you are moving in the train. You agree with me? Now leave me.
Yes.
Now leave me. Now I am the surrounding. Okay, I am the surrounding. So with my reference, I find that the train is moving. Understand? Now you are with your
Okay.
friend in the train. You are with your friend in the train. Yes or no?
Yes, ma'am.
Okay, fine. Now, what is happening? The person who is sitting next to you, is he in motion? No,
No, ma'am.
because that person is at rest. The person is sitting next to you. Even you are at rest. You are not changing your position, are you? You are not in motion. Why? Because you took yourself as the surrounding, as a reference, so that you can measure or you can define the motion of your friend or your co-passenger. Do you understand now? For any motion,
Yes.
there should be a change in position. So in the train itself, see, the train is moving. That means even you are moving. You are in motion, but actually you are not in motion. Why? Because you have not changed your position. You are seated on a seat. Do you understand?
Yes, ma'am.
All of you,
Yes,
beta,
ma'am.
ninth standard. All of you have
Yes.
understood what I'm saying. You have
Yes,
to
ma'am.
understand it. Then only you can do numericals. Then only you can define the distance and displacement. Okay? Now all of you understood the train is moving, no doubt about it. But you are not in motion. Why? Because you have not changed your place according to the time. Have you understood now?
Yes, ma'am.
Yes, ma'am.
Thank you. Again, the same thing, but in a different aspect. What do we mean by with respect to the surroundings? So now we are going to define more of surroundings. Yes, beta. So anyone who wishes to read it can do that. All of you should get the chance, beta. So please come ahead. If no one is there, then better you carry on, okay? If no one wants to, then you
Okay,
carry on.
ma'am.
Next,
Okay, ma'am.
Yes, better.
no,
Yes, start.
we know that a moving train is in motion because its position changes with time. Now
Okay.
consider a person sitting in
Consider.
the train. Consider a person sitting in the train. For someone standing on the platform, the person sitting in the train is in motion. But
Do you
for
agree?
the co-passenger,
Just a
the
moment.
person
Just a
is
moment.
the rest.
Just a moment, beta. When I stop you, please stop. What I said, do you agree whatever is written over here? That for someone standing on the platform, the person sitting in the train is in motion. Do you agree with it?
Yeah,
Yes.
ma'am.
Yes. So I become the reference point, isn't it? That I am standing on the platform. So I become the reference. So according to the reference, the train is moving because I am not moving. So the train is moving. Understand? Understand or not? Yes?
Understood. Yes, ma'am.
Okay. Okay, better.
Yes,
Now continue better. But for the co-passengers, yes, better, I'm waiting.
but for the co-passengers, the person is at the rest as the position of the person does not change with time.
Okay.
Therefore, we need to consider the surroundings of the point of
Or-
observation while describing the state of motion of an object.
Okay.
The
So,
surroundings is called reference frame.
so you understand now? I was on the platform, and the train is moving, and you're in the train. So I become the reference. I become the surrounding. Yes or no?
Yes, ma'am.
Hello? Yes. Then only I
Yes,
can say
ma'am.
the train is moving. You got it? So until unless I take a reference, I cannot describe the motion. Do you understand? So there has to be reference,
Yes,
then
ma'am.
only I can decide whether the object is moving or not. Do you wish me to explain it more or do you wish me to go ahead? Have you understood this now or not? Clearly, I want it clearly. So I've taken three slides on the same matter, on the same aspect. It is very, very important. You have to understand this, then only we can define the rest of the faculties of motion. All of you have understood whatever I taught you just now.
Yes, ma'am.
Any
Yes, ma'am.
problem? You can ask me right now so I can define it again. Then only I can go to next slide. No problem, beta?
No, ma'am.
No problem, ma'am.
Thank you, beta. Now here we do it again. Now we are going to work in detail. Okay? A bit of revision and bit of detailing. Okay, start. Describing motion. Now let's, how do we describe motion one by one? Let's start. And if you can explain, we are welcome, beta. If you can explain motion, I will be very happy. Please start. Yes, but start.
Um, Describe motion. Motion is the change in the position of a body with time. Motion can be described in terms of the distance moved for the displacement.
Or the displacement. And you have to read it properly. There's a full stop. You have to pause at the full stop, beta. Take care.
Okay, ma'am.
Okay? If there is no usage
Okay,
of
ma'am.
particle, you will not use it.
Okay.
So motion, I think you have understood what is exactly motion of any object. That means there is a change in position. There is a change in position. And with what is the reference that we are taking with time. Okay, now let's see what is
Okay.
distance. Start with distance.
This distance moved is the actual length of the path traveled by our body.
Okay, so length. Now length can be covered by, can be denoted by centimeter or meter or kilometer. What do you say? Yes or no? Yes,
Yes,
or
ma'am.
millimeter or millimeter. Millimeter, centimeter, meter or kilometer. So this is how we measure the distance. You agree all of you?
Yes, ma'am.
Hello? Okay. Now we are going to work on the new topic altogether, that is displacement. Start.
Displacement is the length of the shortest path traveled by body from its initial position or to its final position.
Fine. So you just understood? This is the shortest part. This is the shortest part when a body is traveling from initial to the final position. Okay, start.
This position. If a body starts moving in a straight line from origin O and moves through C and B and reaches A and then moves back and reaches C through B,
Then,
then distance travel is equal to 60 plus 35 is equal to 95 kilometer. Displacement is equal to 25 kilometers.
now leave it. Okay, now we are going to work. Yes, see. Now a body is traveling in a straight line. Now, this is O. It's starting from O, it goes from C, it goes from B, and then it is reaching A. Yes or no, beta? Hello?
Yes, ma'am.
Okay. Now this is 0 kilometer and this is 60 kilometer. So from here to here, what is the distance, beta? What is the distance?
60 kilometers.
60 kilometer. All of you agree?
Yes, ma'am.
All of you agree? Now the next is, so we got 60. Then, now the next question. It moves back. Now it went like this. Look at my arrow. And then it moves back and reaches C. So now from here it is coming back. When you see, observe, and it reaches C. Yes or no? Better. Yes or no?
Yes, ma'am.
Yes,
Okay?
ma'am.
Fine.
Yes, ma'am.
What happens? Now this is, what is this distance? This distance will be 60 minus, how much it is, beta? 25. How much is C? 25. So 60 minus 25 is, how much it is? 35. Yes or no? This is 60 and this is 25. So 60 minus 25 becomes 35. You agree?
Yes, ma'am.
And how much it becomes?
Yes, ma'am.
How much it becomes? 95 kilometer. This is distance. Remember that. This is distance. Have you understood now? The complete distance travel from O to A and then it comes back from A to C. So what is the distance? 60 plus 35. We got 95 kilometers distance. The body has reached C. Now the next question is, what is the displacement? We have already read that the shortest distance. What did you read, beta? It is the shortest distance. What was the initial, beta? 0. What is the initial? 0. Agree, beta? Hello, boys.
Yes, ma'am.
Yeah. What is the final?
25.
It reached C. That is the final because it went from 0 to A, sorry, O to A, and it came back to C. So the body is at rest at C now. It has stopped at C. So what is the shortest distance?
25.
25. This is your displacement. Now, did you understand the difference between distance and displacement? Okay, I give another answer. You are a swimmer, okay? This is a starting line. You are over here, right? You are at rest. Then you dive. You go and then you come back. For example, this is 100 meter. I'm asking you a question, better. This is 100 meter. One lap is 100 meter. And then again you come back. So what is the distance? Can you give me the
200
distance?
meters.
How much?
200 meters.
Very good. Distance is 200 meter. Now if I ask you the question, what is displacement? What you will say? Fast. What is the displacement? Can anyone give me the answer? You're perfectly right that the distance is 200 meter, 100 going and 100 coming back. But this person, when he started with the track, with the swimming, and then he comes back again over here. So I'm asking you, what is the displacement? He comes back to the same position. What is the displacement? This is the shortest distance, remember that. So this is the initial and this is the final. So what is the displacement? Any guesses? Don't keep mum better. You have to. You should give answer. Then only you will learn more. Can anyone give it a try? So maximum you will go wrong. Doesn't matter. But you should give it a try. Always. Yes, beta. Arman. Sahil? Okay, any wild guesses? Hello? Can you hear me?
Yes, ma'am.
Okay, so what I said, he started from here and he came back. So what is the displacement? What did I teach you just now regarding displacement? This is the initial and this is the final. So what is the displacement? There has to be something, no? We measure always. Remember this maths. We always measure it. So what is the displacement? It is zero because the initial and the final are the same. Understood now?
Yes, ma'am.
This is what I want to check. Okay? Fine. I hope you have understood the difference between the distance and displacement. I can give you another one. Now, I take a circular path. You know, we do the relay race, remember? We do the track,
Yes,
100 meter, 200, 400, 800 meter, remember? So this is a track. So I start my, this is say 400 meter ramp. Okay, this is 400 meter. I start and then I come back to the same position. What is the distance covered? Hello, what is the distance covered?
0.
I said distance better. Now you're confusing.
400 meter.
400, exactly. Distance is 400. And what is displacement?
0.
It is 0. Now you understand? Is he started from here, like you started from here, and you came back here to the same place. So displacement, the shortest distance, that is 0. And the distance that you moved from here to the final position, that is distance. Have you understood now? Because this is what
Ma'am.
you have to do in numericals. If you are not clear, then you will find a bit of difficulty in the mathematical equations. I hope and I pray that all of you have understood the concept between, or the concept behind the distance and the displacement. Have you understood all of you?
Yes, ma'am.
All of you. I said only one is saying yes, ma'am. Have you understood? Boys, if you have not, then stop me right away. Then I can explain it again. Yes, beta? You have to answer whether yes or no. Okay, then I take it for granted that you know everything. So we go to the a new aspects altogether is called physical quantity. It is called physical quantity. What are physical quantity? Let's see. Yes, beta. Read. Hello.
Yes, ma'am.
Please read.
A physical quality is
Quantity.
any quantity is any physical property that can be expressed in number. For
Okay,
example,
that is one
time.
thing. Yes,
For
yes, read.
example, time is a physical quality, as
Quantity.
it can physical
Quantity.
quantity as it can be expressed it in number, but arranged it not
Anger.
as
Anger. Anger.
but
It is anger.
anger is not as in cannot be expressed in number.
I hope you have understood. Now, a physical quantity is what? That means you can count it. You can show it in numbers. Now, over here, you can see the numbers. Yes, you can see this numbers 4, 10. Now, you are angry. Can you see the number? Can you see how much angry you are? 1, 2, 3, 4 till 100. Can you show?
No, ma'am.
Hello? Okay. So, understood now? So, physical quantities, again, Read it.
Physical quantities can be classified into two types: squirrel quantities,
Scalar, scalar.
scalar quantities, vector quantities.
Okay, so now we are going to read about two quantities. That is, one is scalar and the second one is vector quantities. Okay. First, we are going to read scalar quantities. Yes, better.
If a
Read
physical if a physical quantity can be complete described only by its magnitude,
magnitude,
then it is a scalar
scalar
quantity.
quantity.
To measure the mass of an object, we only have to know how much meters is
Matter.
present in
Be
matter
careful. Please be
is
careful. Present.
matter is present in the object. Therefore, mass of an object is a physical quality
Quantity.
that only quantity that only require magnitude to be expressed. Therefore, we say the mass is a scalar quantity.
Scalar quantity. Understood? Okay. Then please write. I mean, please read. Sorry.
We can add scalar quantities by simple arithmetic means.
What does that mean? Simple arithmetic means addition, plus. You understand? The arithmetic means are plus,
Yes,
minus,
ma'am.
multiplication, division. Do you understand? These are the arithmetic means. Now over here, what are we going to? We are going to add. Now mass, you can see the value 10 kg is written over here. Can you see the 10 kg? So this is a
Yes, ma'am.
scalar. Why? Because I can see only mass. Now let's see only mass. That means I can count. That is the magnitude. You can measure the quantity. Now let's see what it is vector. So you know you will understand the difference between both the quantities, physical quantities. Yes, read better.
Vector quantities. There are some physical quantities that cannot be completely described only by their magnitude. These physical quantities require direction along with magnitude. For example, if we consider force, then along with the magnitude of the force, we also have to know the
Direction.
direction
Understood
the
now?
direction which along with the force is applied. Therefore, to describe a force, we require both its magnitude and direction. This type of physical quantity is called a vector quantities.
Now,
Vector quantities cannot be added or subtracted by simple arithmetic means.
now have you understood? Have you understood the difference between scalar and vector quantities? Scalar is only you can use arithmetic means. You can add. In vector quantities, you cannot add or subtract. Do you understand? In scalar quantities, there's the matter, the mass, the quantity. Whereas in vector quantities, we have quantity, yes, no doubt about it, but we need that direction also. This is the difference between scalar and vector. So what is scalar beta? Magnitude, that is the mass. What is vector? Magnitude plus direction. What is scalar? Addition can be done. What is vector? No addition, no subtraction. Have you have you observed the difference between scalar and vector quantities better?
Yes, ma'am.
All of you have understood. So these are small, small things that you really have to understand. Okay, because we are going to work on acceleration, we are going to work on speed, displacement, distance, and then we have to categorize it, whether it comes under scalar or it comes under. Now you are going to define. I'm going to ask you, now better let me know whether acceleration is scalar or vector, speed is what, velocity is what. You have to define it to me. If you understand this, then only you can define. Is there any problem regarding these two physical quantities? All these are new terminology to you, beta. That's why I'm asking you again and again. Have you understood? Then only we'll go to the next slide. Ninth standard boys, have you understood the differences between scalar and vector quantities?
Yes, ma'am.
Fine. So I think we call it a day. This time is already up. And please revise whenever the video gets uploaded, it comes to you uh, without fail, beta. Just promise me that you
Okay.
will revise it without fail. Okay, beta? Okay. Have a good day. Have a good day. Bye.